Alright, pre-calc students. So, our last video is kind of a combination of chapters 8 and 10, and we're doing a combination just because you guys just did these chapters, okay? So these should be a little bit more like fresh in your memory, fresh in your mind. So we will do a few problems to help us kind of remember the ideas of the chapters. But again, I mean, this is just a refresher. You're probably going to want to study a lot of different types of these problems, right? Like on this video, I'm not doing 8 different word problems. I'm doing one to kind of give you a refresher, and you have to go from there. All right, so let's get started. We have a man that can see the top of a tower by looking up at an angle of elevation of 35 degrees. All right, so I'm going to draw that. Absolutely going to draw that. So maybe something like this. Here's my tower, and I know angle of elevation, 35 degrees. All right, so we have that, and it then says that he moves 50 feet closer. All right, so 50 feet closer means he's going towards the tower, but now he can see the top of the tower with an angle of elevation of 75 degrees, all right? So maybe something like this. All right, and what does that mean? Well, that means that my 75 goes right in there. If you notice, it says, well, to draw the diagram, we already did that. Find the height of the tower. Okay, so I'm looking for the height. There's some more stuff I should add into my picture to be very thorough. First of all, these are right angles. Or these are right triangles, I should say. So that's really important because that means that we could use SOHCAHTOA if we have enough information. I also need to put in this distance, right? I know that this was a 50. Alright, so now the idea here is that I don't have any information about this little right triangle or this big right triangle. And by that I mean I don't have any full side lengths, right? I got this 50, but it's not the full side. So I cannot use right triangle trigonometry yet. Alright, so we're going to have to do some extra work. And by that I really mean, well, I can get some other angle measures. 75 means that this is 105. And if this is 35 and 105, that 140, that means that this right here has to be a 40. And that's super important. I need that because now that I have all 3 angles of this triangle, I can solve for one of the sides. Personally, I would pick this one because it's part of this right triangle, and then I can work off of this side to get the height. So I'm going to call that x. And now remember, if you have angle pairings, right, if you're in I guess in this case I would call it a angle side angle situation, ASA. That's the law of sines. So we're going to use the law of sines. So I'm going to set this up as, well, I know the 50, I know that's across from 40. So sine of 40 over 50 equals, and if I want x, well then I need the angle across from x, which is 35. So sine 35 over x. Now if you remember correctly, we're going to do some cross multiplying and solving for x. I know that I would end up having to multiply sine 35 by 50. So x equals 50 sine 35, but then I would have to divide it by sine 40. If you remember correctly, if you want to have an idea of what this value is, feel free, but I know that I'm going to have to do more calculations, so I'm just going to leave it like this. Because the second part now is, now that I know this piece, this x, well, now I can use right triangle trigonometry. I can say, well, let's see, opposite over hypotenuse, excuse me, sine of 75 has to equal h over x, or h equals x sine 75. And so now I would go ahead and I would plug in my x value. All right, so let's see here. X is fraction 50 sine 35 sine 40 is that, and then times by sine 75. And when I hit enter, I get about 43.10. So I'll say that h is equal to 43.10, and we were in feet. Alright? Okay, so again, that's one word problem type. There were lots of them. Study them. Okay, good. This next one I thought went pretty well on the test, so I'm not too concerned, but please remember that we want the shaded region. We call it a segment, and to get a segment, you must, I should say the area of the segment, you must get the area of the whole circle. Oh my gosh, why am I saying circle? Sector. And then you have to take away the area of the triangle. Alright? By that I mean, I can get the entire sector, not the best picture, but we can get that entire sector, and then if I take away the triangle from there, what am I left with? Well, I'm left with what I want. I'm left with this shaded part right there. Okay? Let me just fill that in so it looks a little better. Okay, so this is the idea. You got to get the sector, you got to get the triangle, and then you got to subtract. You got to find the difference. So, area of a sector, hopefully we remember, is a fraction of the total area of a circle. So by that I mean I'm going to use m over 360, and m just can be any angle, right? But I know that because I'm talking about area, it's going to be a fraction of the area of a circle. So I'll have to use that. So let's plug some stuff in. I know that my angle is 70. I know that my radii are 13. Oop, I missed the pi. 13 squared. Alright, so 70 over 360 times pi times 13 squared. Let's see if it'll do that nicely. I'm not sure. I'll leave it like that for now. So 1183 pi over 36 would be my area of the sector. And then for the triangle, guys, please remember all radii are congruent, correct? So if this is 13, then this is 13. And then I have SAS. I have two sides and the included angle. So what I'm going to end up doing is I'm going to use 1/2 absync, as my geo students like to call it. Alright, I know that if I don't have two sides that are perpendicular to each other, well then they're not bases and heights, but I could use 1/2 AB sine C. So 1/2 13 times 13 times sine of 70, that's not going to be a very nice number. 0.5 times 13 times 13 sine 70. And we get 79.40. 79.404, whatever. Here's the deal. Remember, I don't like to round until the very end. So remember, what you can always do is you can store this value. I'm going to store it as letter Z, because now I can go ahead and I can say 1183 pi over 36 minus Z. I guess I could have just said answer, but whatever. And I get 23.83. So 23.83 meters squared. Okay? Cool. Here we go, we're moving on. We have a triangle here. And hopefully you guys notice right off the bat what you're given. You're given side-side angle, or you're giving two sides in a non-included angle. So SSA, this was our ambiguous case, which means we're going to go law of cosines to start this guy. Alright, now please remember, the angle always dictates how you start this. So let's actually first, so we're going to say C squared equals squared plus b squared minus 2ab cosine c. So please remember that formula. But now we know what's going to be my angle. Well, it's the angle that's given, right? It's the 42. So if c has to be 42, then the side across from it has to be on the side of the formula by itself, okay? So it's going to have to look like this. And I don't know this, so yep, b squared minus 2 times 7.2 b cosine 42. All right, the setup on that is really important. Please, 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 please remember, like, you don't have to memorize all of the different ways to write this. You just have to memorize the fact that if the angle that you're starting with has to go over here, well, then the side across from that angle has to be on the side by itself in the law of cosines. All right? Okay. Now, if you remember correctly, this is where we clean up. When we start to try to solve this, we notice that we're going to end up with a quadratic, right? B squared, b. All right? So this is going to be a calculator problem. And then I don't know that. So what's 7.2 squared minus 5.6 squared, 20.48. Okay. That's a B. And that's a B. All right. Hopefully you guys remember what we did here. I just rearranged, right? This is my B squared. I combined the -2, the 7.2 to 14.4. It was all being multiplied by cosine 42, so I left it all like that. And then I just took 7.2 squared and subtracted 5.6 squared to get my c value, or my constant. Because now that I have that, it's time for the quadratic formula. So my coefficient of b squared is 1. My coefficient of b is -14.4 cosine 42. And my coefficient of c, or I guess my constant, 20.48. And I get two values. I get that b should equal 8.21 or 2.5, which then means that I have two triangles, all right? So I'm going to have to split up my paper. I'm going to redraw one of them. Not the best picture, but it'll do. This is always going to be 42. Here's the deal. Like, this can either be the 2.5 or the 8.21. All right, so I'm going to do this problem twice. Now, what's really nice, guys, is when we go and we make our list of all the information, A, B, C, measure of A, measure of B, measure of C, we already have three things, or four things now. I know all the sides for this one would be 5.6, 8.21, and across from C is 7.2, and angle A is 42 degrees. All right, it's going to be the same thing on this next one. So A equals 5.6, B is going to equal 2.5, and C is going to equal 7.2 still. With the angles, again, we need to solve for two of them. We still know that A has to be 42 degrees. All right, so A, B, C. All right, so the idea here is to always, 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 always get the smallest angle first. All right, if I want to get the smallest angle first, then that means in this case, I'm going to get angle C before angle B because side C is smaller than side B. So I'm going to set up the law of sines, and I am going to say that sine of 42 over 5.6, because I have that pairing, is going to equal sine of C over 7.2. All right, when we cross multiply, we get 7.2 sine 42. I'm going to just leave it over 5.6 is equal to sine C, because then hopefully you guys remember 7.2 sine 42 all over 5.6. So 0.8603, well, that's the sine of C, right? that is the ratio. I want the angle, so hopefully you guys remember that I need to take the inverse sine of that answer to get my angle of 59.35 degrees. Now, if we have two angles, we can always just take them away from 180 to get the third. 59.35, and we get 78.65. All right? So there was our first triangle. We have to do the exact same thing with the second. Please be very careful. You want to get the smallest angle first. So that means that we want to get angle B. So when I set this up, again, I'll start with sine 42 over 5.6, but now I'm going to use sine of B over 2.5. And when I do that, 2.5 sine 42 over 5.6 equals sine B. Let's go to work. So 2.5 sine 42 over 5.6, 0.2987. Now remember, that is the ratio. I want the angle. So I second sine the answer, 17.38. 17.38 degrees. And once again, once you have two, you can always get the third by subtracting. So 120.62. All right? All right. So there is that. The law of cosines. Please remember, I'm not, like, this is a multiple choice test. I'm not going to make you do all of this work in one problem, but you need to understand how to do things like this in order to solve word problems or other types of problems that we could ask you that require you to use the law of cosines. And now lastly, just to kind of quickly review one conic section. This should look very familiar. We just did this. We want to put this into standard form, right? I'm going to give you we're going to give you general equations, and you need to kind of figure out what type of conic section it is. So to do that, to start that, we need to complete the square, maybe multiple times. So I'm going to rearrange, and minus y squared plus 4y equals negative 16. Alright, hopefully you remember this. You want to get the x's together, you want to get the y's together, and now we can definitely see that we're going to have to complete the square twice. I'm going to factor out this 4. When I do that, I'm left with a negative 6x, and I know that I'm going to have to add a blank there. Now, I'm going to factor out this negative. And when I factor out a negative, I'm left with y squared minus 4y plus a blank. Negative 16. And then, of course, if I added 2 blanks on the left side, I'm going to have to add some blanks on the right side as well. Now, what goes in those spots? Hopefully we're getting pretty good at this. I know that has to be a 9, right? Half of negative 6 is negative 3. Negative 3 squared is positive 9. The 9 times 4 is 36. Super important. You guys got to remember, this is not really a 9 being added. You're adding a 9, but that 9 has been multiplied by a 4. Alright, so that's really important. Over here, let's see, y squared minus 4y. Oh, okay, I got a 4 here. But careful, on the right side, what do you actually have? You have a negative 4. Why? Well, because it's being multiplied by this negative 1 coefficient. So when we continue, I now have 4x minus 3 squared minus y minus 2 squared equals, well, let's see, positive 20 minus 4 is 16. Alright, so the last thing we have to do is divide absolutely everything by 16, which means I now have x minus 3 squared over 4 minus y minus 2 squared over 16, and that's equal to 1, which is great because now I know my center. My center has to be at 3, 2. Did I goof that up? No, I think that's right. 3, 2. Let's plot that now before I mess up. We can also get r sub x. We can also get r sub y. R sub x comes from this 4. Remember, it's the square root. It's the square root of 4, so it's 2. Or it's the square root of 16, so it's 4. which is awesome because now I can kind of make that dashed, right? I know that I have to be here. I probably shouldn't have done that, sorry. But I have these places where I know my asymptotes are going to go through, all right? So I could go through this. And I can go through this. And now I have my asymptotes graphed. A couple of other things though, real quick. Please remember, I don't know, like, how do I decide whether I go up, down, or left, right? And hopefully you remember it is the transverse axis. This determines the transverse, the first piece. So because x comes first, I know that I have to put vertices here, and I need to sketch in the hyperbola like that. Alright, so that's pretty important. Just in case we ask you some questions about asymptotes and focal radius and foci, we should talk about that. Now, if you remember, asymptotes, we want to use point slope form. Point slope form. And well, we know they go through the center, so that's nice, but you need to remember for point slope form that m is always going to equal plus or minus r sub y over r sub x. Alright, so in this case, 4 over 2, well, I know my slope is going to be plus or minus 2. So when I come over here, I need to do two different equations. I need to do y minus the center the first time, so y minus 2 equals, and I got to use positive 2. Alright, so when I distribute, I get y minus 2 equals 2x minus 6, or y equals 2x minus 4. Does that look about right? Yeah, it looks about right. So y equals 2x minus 4 is 1 of my asymptotes. But I have to do this again, and I have to use the negative slope. So y minus 2 equals negative 2, x minus 3. Well, when I distribute now, I get y minus 2 is equal to negative 2x plus 6, or y equals negative 2x plus 8. And once again, that looks awesome. It looks like it's going right through it. Y equals negative 2x plus 8. Lastly, very last thing in this video, last thing for any video for us, is r sub f. Okay, r sub f for a hyperbola, if you remember, is transverse squared plus conjugate squared. Alright, so r sub f squared has to equal, well, if my transverse was r sub x, then I need to take 2 and square it, and then my conjugate would of course be 4, so 4 squared, where r sub f squared is equal to 4 plus 16, 20. R sub f equals square root 20, which is also 2 root 5. So now I know r sub f. I know that I have foci that need to go left and right of the of the center. So if my center was at 3, 2, well, I need to, the foci, are going to be, again, to the left and right. So that's going to affect the x value. So I'm going to add or subtract 2 root 5 to the x. And of course, the y value of the foci are going to have to be the exact same as the y value of the center, because they're not going up or down at all. Right? They're not going up or down. They're just going left or right. So now the very last thing we should probably know about, I don't know, root 20. It's between 16 and 25, so I'm going to say like, I don't know, 4.4-ish. Because now I can go 1, 2, 3, 4 about there, and 1, 2, 3, 4 about there, and call these my foci. Alright? Holy cow. Long video to end it. I guess that's kind of fitting. I have loved having you guys. It's been great making videos for you guys and working with you. So yeah, study hard. Good luck. And we will, of course, have a couple more days to practice before your final. Alright? Have a good one. Peace.